Welcome to YQ Academy Threads Java Interview Questions and Answers. 1. In how many ways can we do synchronization in Java? 1. Synchronized methods. You can use the synchronized keyword to declare methods, making them synchronized. Only one thread can execute a synchronized method at a time, ensuring thread safety. 2. Synchronized statements. You can use synchronized blocks to synchronize specific sections of code instead of entire methods. By using the synchronized keyword with an object as a lock, you can ensure that only one thread can execute the synchronized block at a time. 3. Lock objects. Java provides the lock interface and its implementations, such as reentrant lock, which allows explicit locking and unlocking of sections of code. Lock objects provide more flexibility and control compared to synchronized methods and blocks. 4. Volatile variables. The volatile keyword is used to declare variables that are shared among threads. It ensures that changes made to a volatile variable are visible to all threads, providing a form of synchronization. 5. Atomic classes. Java provides atomic classes such as atomic integer, atomic bourne, and atomic reference, which offer atomic operations without the need for explicit synchronization. These classes are designed to be used in concurrent scenarios and provide thread-safe operations. 6. Thread-safe data structures. Java also provides thread-safe data structures such as concurrent hash map, concurrent linked queue, and copy on write list that are designed to be used in multi-threaded environments without the need for external synchronization. 2. What are synchronized methods? Synchronized methods are methods that are declared with the synchronized keyword. When a method is synchronized, only one thread can execute it at a time, ensuring that multiple threads don't interfere with each other when accessing shared resources or critical sections of code. When a thread enters a synchronized method, it acquires the intrinsic lock, also known as a monitor lock associated with the object on which the method is called. This lock ensures that only one thread can execute the synchronized method at a time, providing mutual exclusion. 3. When do we use synchronized methods in Java? 1. Shared data access. When multiple threads need to access and modify shared data, using synchronized methods ensures that only one thread can access the data at a time, preventing data corruption or inconsistent state. For example, if multiple threads are updating the same counter variable, you can make the methods that increment or decrement the counter synchronized to avoid conflicts. 2. Accessing shared resources. If multiple threads need to access shared resources, such as a file, database connection, or network socket, synchronizing the methods that interact with these resources ensures that only one thread can access them at a time, preventing conflicts or concurrent modifications. 3. Critical sections. Synchronized methods are often used to protect critical sections of code where a specific sequence of operations or checks must be performed atomically. By synchronizing the methods involved in the critical section, you ensure that the sequence is executed without interference from other threads. 4. Thread-safe classes. Synchronized methods are used in the implementation of thread-safe classes and data structures. For example, synchronized methods are commonly used in the implementation of synchronized collections like vector or hashtable to ensure that the operations on these collections are thread-safe. 5. Coordinating thread execution. Synchronized methods can be used to coordinate the execution of multiple threads. For example, you can use a synchronized method as a synchronization point where threads wait until a certain condition is met before proceeding. 4. What are synchronized blocks in Java? Synchronized blocks in Java are used to create sections of code that can be executed by only one thread at a time. They provide a way to synchronize access to shared resources or critical sections of code without synchronizing entire methods. Synchronized blocks are defined using the synchronized keyword followed by a block of code enclosed in braces. Here's an example of synchronized blocks. In the above example, the synchronized blocks are used to ensure that the increment, decrement, and getCount methods of the counter class can be accessed by only one thread at a time, ensuring thread safety. The lock object is used as the synchronization object, allowing multiple methods to synchronize on the same object and achieve the desired synchronization behavior. 5. When do we use synchronized blocks? 1. Accessing shared resources. When multiple threads need to access a shared resource, such as a variable or an object, it is important to synchronize the access to prevent trace conditions and ensure thread safety. Synchronized blocks allow you to specify the critical section of code where the shared resource is accessed, ensuring that only one thread can access it at a time. 2. Fine-grained synchronization. Sometimes, it is not necessary to synchronize an entire method. In such cases, synchronized blocks offer more flexibility by allowing you to synchronize only the necessary parts of the code. This can improve performance by reducing the scope of synchronization and minimizing contention among threads. 3. Avoiding deadlocks. Synchronized blocks can be used to avoid potential deadlocks in scenarios where multiple threads acquire locks on different resources in a specific order. By using synchronized blocks with careful locking order, you can ensure that threads do not enter into circular dependencies and deadlock situations. 6. Advantages of using synchronized blocks. 1. Granularity control. Synchronized blocks allow you to synchronize specific sections of code, giving you more control over the synchronization process. This allows for better performance as you can synchronize only the necessary parts, reducing the overhead of locking and unlocking. 2. Flexibility. Unlike synchronized methods, which lock the entire method, synchronized blocks allow you to synchronize only the critical sections of code. This allows other non-synchronized parts of the method to run concurrently, improving concurrency and responsiveness. 3. Inter-thread communication. Synchronized blocks can be used in combination with other synchronization mechanisms, such as wait/notify or condition variables, to facilitate communication and coordination between threads. This is useful in scenarios where threads need to wait for specific conditions to be met before proceeding. 4. Deadlock avoidance. By carefully controlling the locking order within synchronized blocks, you can avoid potential deadlocks where threads get stuck waiting for each other indefinitely. This is the end of our Java interview questions. We hope you enjoyed learning with YQ Academy. Until another time, goodbye.